So, hello everybody, and good evening from Sarawak, from Borneo. Okay, so right now it's 4:26 p.m. here on 4 August 2026. So, yay, another new month of August. And yeah, we are basically 8 hours ahead of the universal time coordinate, in case you want to know. So, just another good day there. And yeah, fortunately, I have a little bit of break, so it's fine. But anyhow, I've already test everything else. What do we need for the sound and what's on? So yeah, maybe there's going to be a slightly little bit more kinds of adjustment. Maybe just a bit. I'm currently testing out a bit because I don't want when I try to commentate something, my ears goes a bit, how do I say, a bit, it's not ringing, but it's just like it's going to distract me from talking about the topic, which is why sometimes you see why I do too much pause and whatnot in between of the launch as well. So that's why. But otherwise, we shall be good. So let's go. So hello everybody, and good evening from Sarawak, from Borneo. It's for August 2026 on, what is it? Yeah, Tuesday. Right now, our time right now, we are basically 8 hours ahead of the universal time coordinate. It's right now on 4:21:33 p.m. Yeah, 37 p.m. here. So that's that. And he- hello everybody again. I'm Daniel Suga, your host today for us to watch the launch of the CAS's Long March 8A rocket. They will be carrying nine nine SatNet LEO Group 23, if I remember correctly. Yeah, SatNet LEO Group 23 launches. Yeah, so there's of it in a constellation together. And this one also this one actually known as the Xingwang Digui. Yeah, apparently. Sometimes there are some things like some kinds of other designation and whatnot, but is what it is. Okay, and it's pretty normal, pretty typical here and there. But anyhow, before we are going to the launches, or maybe I can give you straight here so you know that the life is here. So let's go. And here is the launch. I mean, so far not yet launching, it's still ongoing process here and there, so it is what it is. And yeah, and for these launches, in case you are very curious, or maybe let me, let me see, can I adjust this a little bit while we are still waiting? I believe we still can, so give me a little bit of time, but otherwise we shall be good. Okay. Ooh, actually, you know what, that's not bad. That's not bad. Mm-hmm. I need to zoom a bit so it's not going to cut the pixel off. Yeah, sometimes you need to do some slight of adjustment. You need to go something like this. Yes. Okay, another one. Good. Are we good there? Yes. Yes. Okay. Anyhow, good news. So I've already adjusted. We shall be able to go. So you you can see I'm actually, if you can hear the clicking of the mouse, I'm using the OBS. Usually, whatever streamers, whatever nowadays just go and stream around. So that's what I'm using, in case you're very curious. Okay, and I'm very happy with the result. So there you go. Now this is as complete as we can get. Okay, and this is not bad. We are still waiting in for the launch. Yeah. So give me slight little time, but however we are a bit okay. Okay, we are still waiting. But anyhow, before we are fully going in for the launches, why not I'll introduce you a bit what this rocket is all about right now. As you can see, if you see from the designation on the first on the core first stage rocket rocket stages there, boosters there. Oh, why do I actually repeat that word stages? But whatever. If you see the CZ-8A, that this one is best. CZ actually stands for the Changzheng, or in English it would have been pronounced as Long March 8A. So basically that's it. And from my understanding, up until the Long March 5, yeah, from the Long March 1 to Long March 4, basically it's based on the Dongfeng 5 ballistic missiles, okay, which is apparently still in use till this day. In case you're very curious about all of this, how do I say, the nitric acid kind of cloud, especially the afterburn result. That's basically based on the Dongfeng 5 ballistic missiles, and then they just stretch it out into the usable orbital rocket. But that one is considered a bit for longest time, around up until around recently in 2010s. And after that, around 2010s, if I remember correctly, the Long March 5 is basically, no, it's not Long March 5. If I remember correctly, is it Long March 7? Yeah, if I remember correctly, Long March 7 or Long March 6. Between these, that one is basically where the Long March rocket series afterward, anything after that, Long March 5 and above, they no longer use this hypergolic propellant, which is, if you like to be very specific, it's actually uses the unsymmetrical dimethyl hydrazine. That one, if I remember correctly, that one is the fuel, okay, and the oxidizer itself is the D-nitrogen tetroxide. When when these two combines together, at least for the Long March 1 until Long March 4, when you burn this together, it's instantaneously burns, and that's how you were able to lift the rocket itself. But there's one bigger problem, however, environmental cost problem, and especially how do you control it. So I can say it's pretty nasty, pretty nasty pretty nasty rocket propellant combination. Usually, not even the most the most die-hard rocket scientists really want to go very near to it, okay? And that one is super toxic. You don't want to go very near to it, and hence why in the recent year, at least from what I can tell, with the China space program, in case you want to know, they recently kind of switched to a few variant of the rocket propellant itself. If I remember, especially on the private sector, they uses the Metalox rocket propellant. If I remember correctly, the Land Space's Juku 2, it's basically the first orbital the world's first orbital rocket that uses this Metalox rocket propellant, which is the liquid oxygen is the oxidizer and the liquid methane as the fuel. Yeah, for the longest time, usually it's either this traditional Kerolox propellant, which the same oxidizer, but the fuel itself is using the super refined kerosene, which is basically a fuel, also pretty clear color, that contain little to no lead contamination, to ensure that whenever it burns, it will burn much more completely, and it's not going to damage the rocket engine for its whole course of burning cycle. Because especially you need to remember, this rocket usually, whenever they burn, it's going to burn, if not tens of kilograms, it could have been hundreds of kilograms, sometimes even tons of per kilogram per seconds. So when you consider about this even slightly more lead contamination, it can eventually damage and wear and tear the rocket engine itself. So that's why usually traditionally they will use Kerolox propellant, or if it's not using the Kerolox propellant, they will use the hydrolox propellant in the sense that in the sense of similar oxidizer as well, but the fuel is, instead of using all of what I mentioned, it uses the liquid hydrogen. Yeah, for the most part, before liquid methane become kind of mainstay in the rocketry stuff, usually it's either these two kinds of propellant you want to use in the liquid fuel propellant, but eventually they realize as well the super refined kerosene, the RP1, yeah, rocket propellant one, it has one bigger problem because it has more complex long chain kind of carbon and also hydrogen consisting only. That's why it's called hydrocarbon, because it's only contain these two element. Because of this way too much chain stuff and whatnot, it's eventually it's also going to choke the combustion chamber, the rocket, how do I say, the rocket nozzle itself over the course whole period of flight, especially if you intend to use it for a longer duration flight, it's going to pose a tons of problem as well. And also because of this kind of choking, it's also going to introduce tons of other kinds of problem with the, how do I say, with the suit and choking of the suit of carbon burning as well. Hydrogen, it's okay, it's really will be push out just very easily because it's the lightest, if I remember, lightest atom in the known to the mankind. Basically only one proton, one proton and one neutron, if I remember correctly, and one electron as well. So when you try to push it together, hydrogen is good, but carbon, you really don't want to get it very near too much to your rocket engine, because otherwise this accumulation one by one is not only going to choke the rocket engine itself, it's going to produce, how do I say, a very undesirable things with the rocket engine itself, and you don't want it to explode as and also fractured as a result of the pressuring problem. So eventually they go with the hydrolox at some point, but that one is only suitable for the upper stage. Yeah, if you want to know what happened if you uses all of the hydrolox propellant rocket stages, just look at the delta 4 rocket. As a result, it's pretty much massive. Because why? Because the liquid hydrogen actually consumes a lot more of the how do I say, usable volume space, because it's less dense than any of these. It's actually less dense than the super refined kerosene itself, and as a result, usually in order to gain that same amount kind of efficiency with the, how do I say, not efficiency, effectiveness, yeah, effectiveness to the super refined kerosene, the Kerolox propellant itself, they have to supply even more fuel than usual, and then that's also increases the size and the volume of the tank itself, which also causing tons of problem with the mass loaded itself. So to solve this problem, lately what they actually do is pretty interesting. They decided, rather than trying using this propellant fuel and whatnot, why not we switch to something that's commonly people use, and even something we already use in our cooking home, the LNG, the liquefied natural gas. Yeah, and this one is pretty much lately very popular in the rocketry, especially if you see with the Starship rocket and yeah and whatnot. Especially, I've already covered the Starship rocket in the recent IFT-13 integrated flight test 13, or like SpaceX like to call it, flight 13. They basically, when they recently switched to this Metalox propellant, yeah, the liquid methane, because how do I say, from what I can gather, it's basically around 3, 4, 5 times more denser in comparison to the liquid hydrogen. Yet the kinds of efficiency and effectiveness it's basically around the same with the RP1, the rocket propellant one, super refined kerosene, but we fought this huge problem with too much carbon choking stuff and whatnot. So that's why the rocketry main, mainstay with the rocket propellant lately, like at least in the liquid field, they like to go with this kind of combination stuff with either metalox, or at least from another one as well, also existing in the LNG component, with the liquid propane stuff. Yeah, that one is actually currently used by the ESA Aerospace, okay, by the ESA Aerospace with their rocket, which is the Spectrum rocket, okay, and that one is the combination propellant. We call this as Propalox, the same oxidizer, liquid oxygen, but the fuel itself, it's actually uses this liquid propane. Yeah, if I remember correctly, it's liquid propane. And the good news is that the kinds of pressurization, especially if you try to pressurize this propane stuff, fortunately, this is something that's already commonly in the knowledge of, especially in the oil and gas sector, and also technically as well. Maybe I can go a little bit of, how do I say, a little bit of tangent. Technically, in at least in Sarawak, we also have this kind of oil and gas kind of industry. So technically, if we want to build rocket propellant tank, we can also use that knowledge to build that as well. Yeah, surprisingly, we can also we can also transfer this knowledge. But anyhow, just to go a little bit of tangent as well. Yeah, when you try to pressurize this LNG, or basically methane and propane into liquid, it's just simple. All you have to do mostly is that you just need to pressurize it. That's basically what you need to do, and it's going to be in the liquid. But the difference is that the liquid methane, you need to make it actually cold. You don't just pressurize it altogether. You have to cool it around negative 154 degrees Celsius. Yeah, for the liquid hydrogen, it's going to be around negative 216 degrees Celsius, if I remember correctly. Very cold. Okay, so that's if you want to pressurize it properly into its configuration flight. But for the propane, from what I know, usually you just only need to pressurize it as well. But if you want to maximize the amounts of volume, the thrust efficiency and effectiveness, ideally you also want to cool down, okay, chill down this liquid propane itself in the first place. So that's basically the some kinds of explanation that I'm giving right now. So yeah, a little bit sorry if I got it way too long, but anyhow, this is the rocket itself, so that's a very good news. And if you see, okay, and in case I would like to tell you right now, the SatNet LEO Group, SatNet LEO satellite itself, it's basically a satellite constellation. Specifically, if we like to be very specific, it's a satellite constellation that will be launching, that's usually operate, sorry, okay, that's basically going to operate around the low Earth orbit, or basically on this low Earth orbit. It's technically, when you make it in a constellation together, there's actually, for my knowledge, actually two types of the constellation itself. If you want to launch it into the low Earth orbit, the first one is the typical Walker constellation. Okay, if I remember correctly, that one is actually going to, the satellite mostly going to the polar orbit, or basically can go from the south to north or north to south, almost around 90 degrees of how do I say, of the orbital inclination, but usually will target around 80 degrees, something like that. That one is the typical, very typical Walker constellation. But however, Delta is a little bit of different. Delta, it's basically intentionally will try goes around 45 degrees, 50 degrees, 60, something like that. Yeah, that one is basically the Walker Delta, slight modification as well from the original Walker constellation. And that one, of course, obviously, were popularized by with the SpaceX Starlink, with the Amazon Leo, and with the ST Space Mobile Bluebird, and so on and so forth, even including the one web satellite itself, just to name it a few. And even to some extent, if we like to say, also with the Iridium satellite constellation, if I remember correctly, Iridium right now, it's basically in the finalization process of being bought out by the Rocket Lab itself. So it's going to integrate together into this satellite constellation. So essentially, Rocket Lab it's going to have its own soft pie for this internet satellite constellation. And anyhow, whether around the Wenchang around the Hainan Island, China, the wind velocity or speed is 11 kilometers per hour. The cloud cover is 100%, and the precipitation apparently looks like 96%, which means that by the time the rocket itself going to launch up to the sky, it's going to facing around the rain kind of stuff. But as long there is no particular major weather constraint, weather red no-go zone, they're still going to launch it regardless. And yeah, this one, just like what I said, this one will be launching from the Wenchang, if I remember, Wenchang space launch site, if I remember correctly, or the commercial, yeah, the commercial one. This one is from the Launch Complex 1. Okay, in case you want to know, Launch Complex 1 is basically just beside the Launch Complex 2. Okay, in case you're very interested. And I'm going to show you how it's going to look like. Oh yeah, and also forgot to tell you, even though there's not much published information about the SatNet satellite architecture itself, but it's basically basically almost identical to the Starlink, but with some domestically built. Some of it were original, but most of it were obviously copied and inspired from the Starlink itself, in the nutshell. So it's kind of flat panel satellite. Yeah, I like to call this kind of Starlink like satellite, and the Starlink itself the flat panel satellite, in case you're very okay with it. Anyhow, we are still looking at the launch pad itself. Okay, still loading in. T-minus 9 minutes and 28 seconds before the flight for the Long March 10 flight. Oh, sorry, Long March 8A flight 10. Oh my goodness, I got a little bit mistaken. I'm very sorry. If I remember correctly, this should be Y29. If I remember correctly, what it should have been. Yeah. So from my knowledge, or basically there is no civil flight designation. Yeah, because last time I tried to find this, I just can't. And anyhow, this one is basically also credit to the Chinese or China spaceflight community, and also to the international rocket launches for providing this stream, so we are able to see this going up soon. Okay, so that's basically it. And yeah, I can show you a little bit few here and there stuff the about the rocket and whatnot. I'm not going to explain too much because otherwise I've already exhausted my explanation in the beginning. So yeah, I'm not going to bore you too much. And yeah, I have the picture-in-picture mod for the live stream itself, so we can go back just in case it will be ready for the launch. And anyhow, this is how it looks like the last time in the Wenchang space launch site. Yeah, I remember it correctly. Wenchang space launch site, the launch complex 1, if I remember correctly. Launch complex 1 actually located around, yeah, around here, if I remember correctly. It should have been around, let me see, yeah, it should have been located around, let me see, if you see on this on the center here, yeah, that one is the launch complex, launch complex 1, and this one is the launch complex 2 for the launch today. Okay, so basically that's it. This is how it looks like. Still on the construction. On this very right side, you can see it's still ongoing building. If I remember correctly, one of the launch complex site there building as well is for the solid rocket propellant itself. So basically, it can be anything, even the Long March. Who knows, Long March 11, whatnot, so on. So this is where they're going to do. Who knows? It could have also been for this series 3 and so on and so forth. Could have been for the Kinetica 1, Kinetica 2 rocket here. Sorry, Kinetica 2 is basically the liquid fuel propellant, but the Kinetica 1 is the solid rocket propellant. So who knows? And as you can see as well, and this one is, I believe, is the water tower there for the sound suppression deluge system there. So to ensure that by the time it ignites, it's not going, the rocket exhaust itself not going to produce too much of these acoustic vibration and whatnot, to the point it's damaged the launch pad itself, and also to ensure that it's not going to be too noisy. Okay, even though using the word too noisy is way too charitable in the sense. And yeah, for the Long March 8A, 8A, it's basically the upgraded version of this already a base Long March 8 rocket here. Okay, I hope you can see. Is it okay? Just a bit. Yeah. So this is it. Yeah. So basically that's it. This is the original base Long March 8. Okay, as you can see, there's some difference as well, including the fairing noscon there. That one is for to expose the satellites, aka the payload itself, to the space environment after it crosses, reaching this 100 kilometers into the space. Usually around 110 plus kilometers, usually the payload frame will be separated. But anyhow, the design base is almost similar, just more. If I remember correctly, the Long March 8A is basically way taller than, a little bit taller than the Long March 8. Yeah, it's just slightly taller, only taller around 16 centimeters, if I remember correctly. Only taller 16 centimeters, mostly due to the noscon fairing. As you can see, noscon fairing itself on the Long March 8A, it's way wider and bigger in comparison to the Long March 8. So that's why if you see lately, Long March 8A is much more in the use in comparison to the Long March into the Long March 8 and its base Long March 8 for only boosters. And anyhow, just to not waste a bit of time in this case of this flight, usually whenever it's going to launch, especially to the payload to the sun synchronous orbit around the low Earth orbit at the altitude of 700 kilometers or 430 miles, it's going to go around it can carries up to 7,000 kilograms or 7 metric tons, around 15,000 pounds in these instances. And the rest of it for the capacity to low of orbit, geostationary transfer orbit, translunar injection, and so on. This one I assume is only for the base Long March 8 with the strap-on boosters, but 8A, it could have changed just slightly a bit. Okay, anyhow, I'm not going to bore you here too much, but just to give you a little bit of idea. Okay, T minus 3 minutes before the flight. Okay, so I'm going to go a bit quick. On the booster side, each of it were powered by the YF100 rocket engine. That one is consuming the Carolox propellant, liquid oxygen as the oxidizer, and the super refined kerosene RP1 rocket propellant one as the fuel itself. And the same can be said with the first stage core boosters there, but instead it's actually powered by the two YF100 clustered together. And Long March 8 and 8A itself, it's basically clustered together with these two liquid fuel strap-on boosters. And for the second stage, it's actually powered by the YF75 rocket engine. This one is the gas generator cycle. The YF100 is basically stage combustion cycle. Okay, I'm going to explain just a little bit, demands 2 minutes. Okay, but the Long March, the YF75 is basically, instead of consuming the liquid super refined kerosene, it's consuming the liquid hydrogen as the fuel, but the propellant otherwise similar liquid oxygen. Okay, this one is YF75, this one for the best, but basically for the 8A, it's basically the upgraded version of the base YF75, so it uses YF75 hash. Okay, this one two clustered together, and that's that. And yeah, not to waste too much time, the stage combustion cycle is basically on the right side. Basically how it operates in the nutshell, similar to the gas generator cycle with the pre-burner chamber, but instead it uses its own dedicated pre-burner chamber to move this turbine together, and some of it goes into the heat exchanger to cool the rocket engine itself before it burns, and then the rest of it goes into the combustion chamber and then burns out. And this is basically how the operation looks like. And that's it. We are not going to waste too much time. Let's go directly to the stream, shall we? Okay, so we are getting ready in. Oh, 30 seconds. Get ready in. Okay, I hope this is good. Okay, 30 seconds. Get ready for the liftoff. T-minus 20 seconds. 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. And we'll see ignition, and we have ignition of the Long March 8A. We have liftoff from the Wenchang Space Launch site from the Launch Complex 1. Liftoff! Carrying the 9 SatNet LEO Group 23, heading to the low Earth orbit around the Walker constellation, or maybe Walker Delta constellation. And here we go from the flight itself. Everything appears to be nominal. T plus 35 seconds into the flight, and that's basically the only view that we can get due to the cloud cover. But otherwise, she have already gone into Mach 0.5, which is half the supersonic sound. Okay, we are getting ready in, as we might have the indication for the supersonic by now. Should be going into the supersonic, and then later on we'll go to the max Q, which is the period region of the peak mechanical stress to the induced to the rocket itself, as it's going faster and lighter, and especially heating to the certain atmospheric heating, not heating, it's certain atmospheric thickness itself. When these two collides together, it's going to induce that maximum pressure aerodynamic there. That one is the most max span period there, and if in case anything else problem with the rocket itself, it can unbuckle itself and destroys itself. That's why it's very important to be very careful around the max Q region there, which is the maximum aerodynamic pressure there. And otherwise, the flight looks pretty nominal, and that's the only thing that we can see due to the cloud cover. T plus 2 minutes into the flight, 120 seconds into the flight. And the view of this is actually brought to you by the China/Chinese spaceflight community via the restream of the international rocket launches. So thank you so much to them for streaming in. But otherwise, that's it. We've already done. and the flight is almost should be around 3 minutes last, something like that. Yeah. But anyhow, in this preliminary launches, all appears to be very good, and that's the most important thing so far. And by this period, I believe the strap on liquid fuel boosters there should have already separated, and then not long after that, the first stage also should have already been separated, and the second stage should have already been ready as well for the ignition, and yeah, continuing the mission altogether. And anyhow, that's basically the entire whole mission. Sorry for a little bit of bummer there. Yeah, due to the cloud cover itself, very thick cloud cover. So we are not able to see beyond the launch on the lowest altitude, but otherwise everything looks pretty fine for the launches. So anyhow, thank you so much everybody for watching. Even though this is quite short, but I really do appreciate it as time still going by. Yeah, apparently as well, the flight is almost 4 minutes into the flight. If you see on this indication, yeah, it's something like this. 4 minutes in, you can see there. And yeah, and also next thing that I would like to stream, but if only there is a stream, if I can find it, it will have been the launch of the GuoWang 3 Smart Dragon 3 all solid rocket boosters. If I remember correctly, this one is the 3 or 4 small lift orbital rocket here. This one would be launching from the Hainan Oriental spaceport around the offshore site. So it depends. If it's slightly nearer to the shore, there is highly likely going to be official stream. But otherwise, if there's nothing, well, we can actually reserve that stream for another day as well. For tomorrow, yeah, tomorrow on 5 August 2026 on Wednesday at 10:35 a.m. here, local time in Sarawak in Borneo. We are 8 hours ahead of the universal time coordinate. So basically, keep this in mind. If you actually visit the next space flight, it could have been different for your experience. So please check on your respective timeline in case you want to know. And yes, also another tomorrow, but this one is in midnight at 12:29 a.m., which will be the launch of the Starlink Group 17-53 on board the SpaceX's Falcon 9 Block 5 rocket, launching from the Vandenberg Space Force Base located in California, US. Okay. However, I'm not going to stream the Starlink since it's already way a lots of launches like this one, so I prefer not to stream that much. Yeah, so and also I rather use my energy for something else, like my kinds of other hobbies as well, here and there. Yeah, it doesn't mean I don't want to stream. It's just like I want to save myself a bit of sanity, and also, yeah, because I also look around and actually kind of share the same sentiment that also people are quite tired looking at these launches as well. So that's why I'm going to use this only for rare opportunity. Probably I'm going to stream this around another 2 months or 1 month in the future, or maybe around 1 to 3 months. Let's see what I'm going to do next. And yeah, and then for tomorrow, yeah, this one is this one which will be launching the Bluebird constellation, Bluebird 11 to 13. Okay, tomorrow at also on Wednesday 3:42 p.m. there, launching also on board the same rocket, Falcon 9 Block 5 rocket, but this time launching from the Cape Canaveral Space Force Station from Florida, US. Okay. And remember, this one is basically using local time here in Sarawak and Borneo, so you have to look at the website or the apps yourself of the next space flight if you want to know the exact time it's going to launch. Yeah, and then another launch, but on Saturday, also I'm not going to stream, is the launch of the Starlink Group 17-38. Okay, this one launching using the same rocket as well. Falcon 9 Block 5 rocket launching on Saturday. Saturday, Saturday. Which day is it? Yeah, Saturday, 8 August 2026. Starlink Group 17-38 launching from this Vandenberg Space Force base from California, US. Okay, and finally, as well for this week, which will be for the Long March 7A launches. Okay, for this unknown payload, I highly suspect this could be something else, or it could have been for Tianfan. Yeah, for the Tianfan 1000 cell satellite, or possibly SatNet LEO. Yeah, space cell SatNet. Who knows? For the Long March 7A launching from the same launch site for today, Wenchang Space Launch Site, which launching from the Hainan Island, China. Yeah, and this one will be launching on Sunday around 9 August 2026 at 7 p.m. here, local time in Sarawak in Borneo, 8 hours ahead of the universal time coordinate, in case you want to know, as a bit of a reminder. But otherwise, that's basically it going to be for this week. And also because, yeah, we've already finished it. Yeah, so thank you so much everybody for watching this stream. I hope you enjoy it, even though we can only watch it like how many, like not even 20 seconds, and after that got covered by the cloud itself. But anyhow, that's it for the launch of the Long March 8A. Thank you so much everybody for watching. Yeah, so thank you so much everybody for watching once again. I am Daniel Suguwa, your host today for this launch of the CASC Long March 8A rocket that are actually carrying the 9 SatNet LEO Group 23 for the heading to the low Earth orbit around, which actually launched as the satellite constellation around the Walker constellation, or typically nowadays it would have been around Walker Delta constellation. Yeah, to maximize the coverage. And anyhow, that's basically it. Thank you so much everybody for watching, and I hope to see you soon later for tomorrow. Yeah, if there's going to be launch of the GuoWang 3, it could have been either these two, GuoWang 3 launches, or the Bluebird 11 to 13, basically 3 Bluebirds satellite constellation launch together. Yeah, and I also forgot to tell you, okay, this one, the launches on board of it, this is not the unknown payload. There's actually 2 payloads on board this flight. Basically, it's called, if I remember, Dongfeng Insights Hyperspectral. That one is the Earth observation satellite there, okay, which launched a pair of it, 2 satellites. If I remember, the first one is the Jinshan star, and the second is the Yinshan star. So that's basically going to be the satellites launching on board that particular mission for tomorrow. Let's see which either of these will be the first for the launch tomorrow. If there's no stream for the GuoWang 3, well, whatever, I still can move on with the Falcon. I can actually go with the Falcon 9 Block 5 rocket launches for tomorrow. It's either these two. But anyhow, thank you so much everybody for watching. I would like to say, please stay safe and take care of yourself. Yeah, especially because of the current weather situation, especially, lots of stuff happening around the world with the wildfire stuff. And even if it's not wildfires, it can also be with the uncertain weather conditions. So please take care, stay safe for yourself, especially on this last stretch of this summer. So please take care of yourself. We will see you soon for tomorrow, if anything goes by. So thank you so much everybody for watching. I'm Dennis Suga for today's stream. Thank you so much, and take care and stay safe. Bye bye. And yeah, and just like the Windows 95, how do I say, Windows 95 shutdown splash screen, you can safely shut down the computer right away after that. you can now safely exit from this stream, as we are going to meet you back soon tomorrow if anything goes by. So thank you so much and take care. Stay safe. Bye bye. And see you soon.